Good morning, all of you. In today's session, we are going to discuss about CSIR and Csir of Chemical Science, June 2014, Part B, Series 3. Earlier, we completed 2016, 17, 18, 19, 20 academic year. Both the session question papers of CSIR and Csir of Chemical Science all are available on the channel called World of Competitive Chemistry. This kind of standard question paper discussion will fetching you towards aspiration for research and also any competitive exams or entrance examinations as well, right? Let us discuss about today's concepts. CSIR NET of Chemical Science, June 2014, Part B, Series 3 consists of question number 56 to 70. Let us go with question number 56. The figure given below represents the path followed by the gas during expansion of A to B. The work done is, right? So this is a question from thermodynamics, and here pressure versus volume graph was plotted, and A point and B point, if A tends to convert it into B, the work done in the system will be 4. Here 4 joules work done in the system, that is option number 4. For question number 56, option number 4 is the correct answer. Let us move on to question number 57. An aqueous solution of optically pure compound of concentration 100 milligram in 1 ml of water and measured in quartz tube of 5 centimeters length was found to -3 degrees. The specific rotation is, this is a part of question from stereochemistry, specific rotation to be predicted, right? So here, in order to predict that, the formula will be specific rotation alpha is equal to alpha by gamma into L. Here alpha denotes observed rotation by the compound, that is given in the problem -3 degrees. Gamma is nothing but concentration of given aqueous solution, optically pure active aqueous solution whose concentration is denoted with gamma, and L is nothing but path length. Within the problem, quartz tube with a path length of 5 centimeters have been mentioned, and 100 milligrams in 1 ml, that is given as 0.01 concentration. When we substitute all the values, -3 by 0.01 into 5, it will become -60 degrees. Specific rotation of given aqueous solution of optically pure will be -60 degrees centigrade. So what will be the formula? Alpha is equal to alpha by gamma into L. For question number 57, option number 2 is the correct answer. Let us move on to question number 58. Two phases alpha and beta of a species are in the equilibrium. The correct relation observed among the variables temperature, pressure, and mu will be. Here, two phases are there. They are said to be alpha and beta phases. Both are existing in the equilibrium. Whenever both the phases are existing in the equilibrium, what will be the relation between the variables? So let us go with the detailed discussion. This is a data collected from NPTEL lecture. The two phases alpha and beta of species are in the equilibrium. The correct relation observed among the variables temperature, pressure, and mu are. T denotes temperature, P is the pressure, mu is a reduced mass. Okay. Whenever two states of matter are existing in the equilibrium, so that generalized equation will be mu alpha is equal to mu beta and T alpha is equal to T beta. A, B are the two phases which are existing in the equilibrium. P alpha is equal to P beta. These three relations will be given in the option number 3. For question number 58, option number 3 is the correct answer. And the next question will be question number 59. The number of configurations in the most probable state according to Boltzmann formula, right? So here, how many probable states are present in accordance with Boltzmann formula? That is given by the S is equal to K into ln W. S denotes energy, K is the Boltzmann constant, W is the weight of the most probable conformation. Now, here S entropy formula is given. Now we have to go with the W. W is equal to e to the power KB. S. KB denotes Boltzmann constant. S is the entropy. E is the log base E. Right. So that is provided in the option number 1. For question number 59, option number 1 is the correct answer. Let us move on to question number 60. The correct match of proton NMR chemical shift of the following species R compound is. 3 aromatic compounds have been given. 1, 2, 3. Then what are their corresponding delta values on proton NMR spectroscopy? Here, when you observe, already we know that aromatic benzene protons will represented in ER by 7.2 ppm. So here benzene 7.2 is given in option number 1 and option number 2. Then we have to go with 5-membered ring and 7-membered ring system. So let us go with all these. So whenever the cyclopentadienyl anion was considered, whose proton NMR shift will be 5.4, 5.5 nearby. So that is given in the option number 1. And tropylium cation, this is the 7-membered ring system with the cationic one, and it is again said to be a aromatic, but it is in the deshielding zone, so that here downfield value can be observed for this molecule, and tropylium cation will observe the proton NMR peaks in nearby 9.2 ppm. So that is given in the option number 1. Benzene ring, all are being equivalent, all are able to give the peaks nearby 7.2 ppm, and this is a characteristic region for aromatic. So aromatic peaks, whatever aromatic compound is given, that will be laying in the region of 6.5 to around the 8.5. So this is the general region for the prediction of aromatic compounds by proton NMR spectroscopy, right? So 5.4 corresponds to 5-membered ring, 7.2 corresponds to benzene ring, 9.2 corresponds to tropylium cation. For question number 60, option number 1 is the correct answer. Let us move on to question number 61. The major product formed in the following. We are taking, what's the compound it is? 1, 2, 3, 4 carbons are there. Isobutanoate, ethyl isobutanoate was given, and sodium triphenyl methane, and subsequently hydrolyzed under SB conditions. Here, the starting material will be CH3CCH3COOET. Whenever it is treated, what will be the final product? This is a kind of this is a kind of Foldal condensation reaction where this triphenyl methane kind of salt will facilitate the reaction where carbene will be originated. Generated carbene will be treated with another mole of ester. Second molecule of ester will be treated with this one, so that here carbene will be bounded to carbonylic functional group, so that we will get a new carbon-carbon single bond origination. And subsequently, O- oxide will be backpolarized, and subsequently this ethoxide will be removed, and we will get a diketone compound in this manner. So simply you can say it is a kind of dimerization process. Disorder kind of mechanism followed in this reaction, right? So that is available in the option number 3. For question number 61, option number 3 is the correct answer. Let us move on to question number 62. In a Diels-Alder reaction, the most reactive diene among the following is. So here, what is meant by Diels-Alder reaction? It is a kind of photochemical reaction concerted mechanism. One of the moiety will be diene, another will be dienophile. Both got interacted, so that cyclohexene derivatives got generated, right? So where electrocyclization reaction got carried, and a cyclic derivative, that is cyclohexene derivative, is prepared whenever we are taking diene and dienophile, right? So it is a kind of concerted mechanism where the important conditions required are electron donating groups should be present on 1,3 butadiene moiety. Electron withdrawing groups should be present on a dienophile. Then only reaction will be facilitated and a product will be formed. Even though so many conditions are there, the suitable condition for this Diels-Alder reaction will be electron releasing agents are required on diene and withdrawing groups are required on dienophile. Then only faster the rate of the reaction and greater the extent of product formation is possible, right? Here, these many options are given, among all which will be more reactive towards this Diels-Alder reaction. All are the kind of dienes only. That means we have to compare all the dienes, and where the reactivity will be higher, that should be facilitated towards more the product formation. So let us go one by one. First one is 4E 1,4 hexa diene. Okay, so at fourth carbon we have E configuration. So in the geometrical isomers, EZ notations which used to impart the orientation of the functional groups around the carbon, right? So E denotes what? If both the alkyl are both the similar groups, the higher priority groups are in the opposite direction, that is called E configuration. Then Z is nothing but if two similar or higher priority groups are in the same direction, that is called Z. Here 4E in the sense one is a terminal olefinic double bond and the fourth carbon with two different alkyl groups are there. So here you can assign this geometrical isomerism, and this is a kind of system. One of the electron releasing group is there. It is a required condition actually. But if another carbon also having electron releasing group, so that electron density on this compound will be still higher, so that reactivity will be still raised. This is the favorable condition actually. But with respect to this, here compound number 3 having two sides electron releasing, then what happens here? More electron density will be accumulated on the diene, and it will be more reactive towards the electrocyclization process. That's the reason why, even though it is a suitable condition, and still more reactive compound is available. That's why we have to go with option number 3 only. And whenever you go with this kind of compound where double bond is arranged in the cis manner, means the two alkyl groups are inclined in the same side, then already we know alkyl groups are very bulky in nature, larger the groups. When larger alkyl groups are present, they will not participate in the reaction more rapidly, because sterically hindered kind of conformation is there. It is not suitable form for Diels-Alder reaction. Obviously, trans conformation, it is a sterically relaxed form, and the hindrance will be very least, so that stability will be higher, and subsequently it will be participate in the higher rate of reaction. So option 3 is the suitable condition in order to facilitate this Diels-Alder reaction. When we go with option number 4, both are in cis conformation only, 2Z, 4Z. When you go with all Z conformation, it never be suitable for the Diels-Alder reaction, because here the high steric hindrance is there, being all the alkyl groups are in the same inclination. So option number 4 can be discarded, 2 can be discarded, even there is a possibility of the reactivity, but in the end a alkyl group is missing. Overall available in case of option number 3 more stable, and methyl groups on the both ends of double bond will facilitate the electron density on this butadiene, and it will be more reactive. Right? For question number 62, option number C is the correct answer. Let us move on to question number 63. Consider the statements about the following structures X and Y. Here is the compound benzyl nitrile, and the second compound where we have carbon double bond NH. So these two are the rearranged compounds of one only, right? Here, when we see this first compound where we have CH2C triple bond N, this is simply called cyano or nitrile functional group. When it participates in the tautomerism, it can be transformed into compound number Y, where it is called ketenamine. So this is known as ketenamine, right? So X, Y both are resonance structures. It is not the correct answer. Rather, both are tautomers. What is tautomerism? Tautomerism is nothing but by shifting of simple functional group. Here what we are doing, hydrogen is shifted from the carbon atom to nitrogen atom, so that cyanide got converted into ketenamine. So here it is the kind of system. Here you can clearly observe carbon nitrogen triple bond is there in the nitrile functional group. Upon tautomerism, here carbon nitrogen double bond, carbon carbon double bond is generated. This is known as ketenamine. Both are said to be tautomeric forms. Then Y is more basic than X. When we compare the basic nature of the both compounds, here you can clearly observe. So basic nature of these two compounds are mainly imparted by the nitrogen atom only. Nitrogen having lone pair of electrons upon that. So release of lone pair of electrons in accordance with Lewis concept, they are behaving like a basis. So nitrogen containing compound due to the lone pair of electrons in accordance with Lewis. So these two are considered as bases. Then which is more basic among these two? When you observe compound number 1, nitrogen is bonded with triple bond. In the second one, nitrogen bonded with a double bond. Nitrogen triple bonded one is called sp hybridized one. Nitrogen double bonded one is called sp2 hybridized. Greater the S contribution, greater will be the electronegativity, and lesser will be the donation of electrons. So that here 50% S character is there in case of nitrile functional group, so that here nitrogen resides electrons tightly rather than releasing in case of nitrile. Whenever you observe this ketinamine, nitrogen being it is sp2, S contribution is somewhat less, 66% of S character is there. sp2 hybridized, what happens? 33% S character and 66% of P character will be there. So that nitrogen is associated with somewhat less amount of electronegativity. Electrons are somewhat freely available for donation. So that you can say this ketinamine will be more basic when compared to cyano-functional group. This purely explained based on its hybridization, based on its contribution of S percentage. Okay, so that is given in the option number C. Y is more basic than X. Y is more basic than X is the correct answer. Y is more X is more basic than Y is the wrong statement. Option number B is the correct one. Both are tautomeric forms, and Y will be obviously more basic when compared to cyano. So B, C are the correct answer for question number 63. B, C are available in option number D. For question number 63, option number 4 is the correct answer. Let us move on to question number 64. Pericyclic reactions involved in one of the steps of the following reaction sequence. Here, starting material, we are taking cyclohexane with S, O, S positive, O minus pH. Here, exocyclic double bond is there upon heating and added with triphenyl ethoxide. Sorry, triethoxyphosphine will be added, and it is converted into cyclohexene kind of ring with a CH2OH functional group. During this transformation, it is obviously sigmatropic reaction only, concerted mechanism of pericyclic reaction. So during this sigmatropic rearrangement, what kind of fragmentation is possible, we have to depict. For that purpose, we are having detailed mechanism for this. Here, S positive, O minus, both are assigned with 1 and 2 numbering. And here remaining 3 atoms, 1, 2, 3, carbon assigned with first, this carbon olefinic double bond second, and this carbon with the third number. So here 3 carbons and these 2 atoms are participating in the sigmatropic rearrangement. Sigmatropic rearrangement is nothing but, so already existing bonds got cleaved and a new bond origination is possible in between through the concerted mechanism. So that this olefinic double bond is migrating, so that here we will get a carbocation deficiency is originated. That will be compensated by this combination with O minus. And whenever it is bounded, subsequently here the bond cleavage between carbon, sulfur and electrons get stored with the sulfur atom being it is positively charged one. So, and we will get this group is now shifted towards this side due to 2,3 sigmatropic rearrangement kind of reaction upon heating conditions. So here within the ring structure, we got a double bond. CH2OS pH got generated in this terminal. In this terminal, we got so this entire group is shifted towards that side. Now, triethoxyphosphine. Triethoxyphosphine, what it will do? So here you can clearly observe that oxygen, sulfur, or both are in the adjacent centers, and both are with the electron pairs, right? Here 2 electron pairs are there, and the sulfur being it is the member of oxygen family, and here also 2 lone pair of electrons will be there. Here both the atoms are very small, and they are associated with the lone pair of electrons and the adjacent centers, which is not favorable. So this bond becomes more labile for the cleavage, and in the presence of this catalyst, it will be the bond cleavage is possible and is turned into a OH functional group, so that we will get cyclohexene containing CH2OH side chain. That is the final product of what already provided within the problem. The mechanism proceeded in this will be 2,3 sigmatropic rearrangement. 2,3 sigmatropic rearrangement is the correct answer. For question number 64, option number 4 is the correct answer. Let us move on to question number 65. Atorvastatin. So it is a kind of medicine which is available in the market and widely used for the treatment of cholesterol lowering drug. And it is made up of this system called what we can say pyrrole, and it is in contact with the benzene ring, and amide moieties are present, and polar hydroxy functional groups are also available in terminal carboxylic acid is there. This is the system So within the problem only this what the structure of the compound and name of the compound they mentioned. Only the thing we have to do is what is its medicinal application. This is a drug which is widely applied for the lowering of cholesterol. So this atorvastatin belongs to the group of medicine called statins. It's used in lowering cholesterol and diagnosed high blood cholesterol. So if cholesterol is there, what it will do? It will increase the blood pressure and consequently heart attacks are possible and heart strokes also possible. So in order to mitigate this type of conditions, it used to dissolve the cholesterol. So cholesterol lowering is possible by the administration of atorvastatin drug. So it is mainly used for the curing of cholesterol lowering. So for question number 65, option number A is the correct answer. Let us move on to question number 66. The maximum bond order obtained from the molecular orbital of transition methyl dimer formed as a linear combination of d orbitals alone is. So here you can clearly observe that whenever this transition metal dimer was taken, means two transition metal complexes got dimerized, and in accordance with molecular orbital theory, what will be the bond order, maximum extent of bond order, how many bonds those two metals are able to form. This is the data collected from Eduncle, that is an online platform for CSIR and HRF. So here the maximum bond order obtained from the molecular orbital transition metal linear combination will be maximum extent will be 5. That means two metals can be bonded up to 5 bonds, not more than 5, less than 5 also possible, but maximum limit will be 5. So that is only possible with the chromium and molybdenum. These two metals are able to form such kind of direct metal 5 bond linkage. So none other than these two metals are able to form such kind of linkages, and it is clearly mentioned in the structure, right? Here you can clearly observe that chromium, these two are the compounds, two different compounds got dimerized. Upon dimerization, there is a possibility of chromium direct linkage. How many bonds are there? 1, 2, 3, 4, 5. So chromium directly bonded with the 5 bonds, so that you can say it is a bond order of 5. So maximum extent d orbitals are able to participate in the bond formation up to 5 only. Only the metals involved in this kind of case will be chromium and molybdenum. So that is available in the option number 3. For question number 66, option number 3 is the correct answer. Let us move on to question number 67. The term symbol is not allowed for NP2 configuration. So when you observe, this is a kind of question from term symbols, group theory question it is. NP2 configuration which is not allowed a term symbol we have to depict. This is the entire data related with term symbol of this one. NP2 configuration when considered. NP2 in the sense, in the p orbital, 2 electrons will be there. These 2 electrons can be arranged in these many ways, right? Here ml denotes what? Ml denotes angular orbital angular momentum. Ml denotes orbital angular momentum, and whose values ranges from +1, 0 and -1, right? So here NP2 will be there if we violate Pauli's law, and if we contribute 2 electrons in the single +1 level, if it is possible. So all possible combinations we will try. So when we arrange 2 electrons in the +1 level only, then term symbol will be assigned for this. The term symbol formula will be L to the power 2s plus 1, and the subscript will be J. 2s plus 1 is called spin multiplicity, L is called term symbol, J is called that is the symbol which is given by L and S values, right? So if we take this type of combination where 2 electrons are present in +1 level, so if 2 electrons present in +1 level, it is given by +1 means L is equal to 2. The value of L will be 2 here. When L is equal to 2 value is given, so corresponding term symbol will be D, right? Because L is equal to 0 will be S, L is equal to 1 will be P, L is equal to 2 will be D, right? So, and what will be the spin multiplicity? 2s plus 1. How can we calculate 2s plus 1 for this? S is nothing but plus half minus half. Both got compensated. S becomes 0 here because both got paid. Now, 2s plus 1 is equal to 2 into 0 plus 1. 2 into 0 becomes 0 plus 1 means 2s plus 1 value will be 1 only. So here for these 2 electrons, the value will be 1d. Value will be 1d. 1d is the suitable orientation. It is possible configuration. What we have to predict, not allowed configuration to be predicted. If you are taking 2 electrons in accordance with Hund's rule. So here first electron, second electron, this is a natural tendency of any metal, which filling of orbitals are possible in this manner only. Electron is present in the +1 level and 0 level. So +1 and 0, L term will become again what? So only +1 is there, so L term is become 1. If L is equal to 1, that is denoted with L is equal to 1, that is denoted with P. So that P is provided in the option number 2. And what will be the spin multiplicity for that one? 2 into +1 plus 1. So +1 plus 1 becomes 1, and 2 into 1 plus 1. So means 2 plus 1, it will be 3. 3p is also allowed one. 3p is also allowed one for the second case. For first case, 1d is the term symbol. For second kind of arrangement, 3p is the arrangement. When we go with this one, third kind of combination, so one electron is in +1 angular momentum level, one electron is in -1 angular momentum level. So +1 -1, now it will become compensated and it will become 0. So L is equal to 0. If L is equal to 0, what could be the orbital? Orbital contribution will be S. So S orbital will be there. The term symbol will be S, and spin multiplicity for this one. One electron plus 1, another electron plus 1. It will become 2 into 1 plus 1 means 3s is possible. Here 1s is given. Let us see 1 is possible or not. For this, it will be 3s. 3s is the possibility. Next, let us go on. Next combination, one electron is with a positive spin, another electron with a negative spin. In this case, s becomes a 0. When s becomes a 0, 2s plus 1. 2s plus 1 can be employed. 2 into 0 plus 1, it will be 1. So here, and +1 -1 orbital contribution, orbital angular momentum, +1 -1 compensated, L is equal to 0. When L is equal to 0, it will be S. Term symbol will be S, and spin multiplicity value will be 1. 1s is also available. Only the provision is 3d is not at all possible. Whatever the combination you can take, you can't predict a 3d kind of term symbol. So 1d is possible, 3p is possible, 1s is also possible, but 3d is not possible. The correct answer for this question, the term symbol that is not allowed for the NP2 configuration will be 3d. That is option number 4. For question number 67, option number 4 is the correct answer. Let us move on to question number 68. If the ionization energy of hydrogen atom is X, ionization energy of lithium +2 will be, right? So ionization energy of hydrogen is given, lithium +2 to be predicted. Obviously, when compared to neutral positively charged ion, in order to pull the electron, so that magnitude will be larger when compared to neutral atom, right? Because whenever positive charge is there, size of the atom will be concised and a nuclear charge will be raised, and that will not facilitate for the removal of electron. What is mean by ionization energy? Amount of energy required to remove the electron from the neutral gaseous atom is called ionization energy, right? Hydrogen only one electron system, being it is one electron system, in order to remove this electron, ionization energy will be -13.6. So when we go with the 60 lithium +2, then what will be the magnitude of this ionization enthalpy? Let us go with the formula. If the ionization enthalpy of hydrogen is taken as X, ionization enthalpy of lithium +2 to be predicted. For that purpose, we have the formula E of energy of hydrogen into Z square can be taken. Energy is nothing but ionization enthalpy of hydrogen into Z square. This is the formula in order to predict the ionization enthalpy of lithium. Then what is the ionization enthalpy of hydrogen? That is given as X. So X into Z. So Z value, charge of lithium, Z values of lithium is given as 3, and 3 square can be taken. So E is given as X. X into 3 square, it will be 9X. 9X is provided in option number 3. For question number 68, option number 3 is the correct answer. Let us move on to question number 69. If the temperature doubled and mass of the gaseous molecule is halved, RMS speed of the molecule will change by the factor of. So what we are doing, temperature will be raised. So temperature is doubled now. Mass will be halved. Whatever mass is there that got halved, then what is the impact on RMS velocity? The formula for RMS velocity is VRMS is equal to root 3RT by M. VRMS is given by velocity, RMS is given by under root 3RT by M. R denotes gaseous constant, T is the temperature in the Kelvin scale, M is the mass of the given gas. VRMS is directly proportional to root T and inversely proportional to mass of the gaseous species we are taking. Initial temperature is denoted as T1, final temperature is denoted as T2. It is double, right? That's why we can write T1 into 2. Initial mass can be taken as M1, final mass can be taken as M2. That M2 is nothing but half of the M1 because the mass got halved during the transformation. Now let us take the ratio between V2 by V1. V2 RMS by V1 RMS is given by under root 3RT2 by M2 by under root 3RT1 by M1. So T2 is nothing but 2T1. Then M2 is nothing but M1 by 2. If we substitute root 3R got compensated, both are exactly equal. All the known terms got compensated so that V2 RMS by V1 RMS value becomes 2. Nothing but V2 RMS is equal to 2 into V1 RMS. Okay, initial RMS speed can be doubled by 2. For question number 69, option number 2 is the correct answer. Let us move on to last question of the series, right? It is a part of electrochemistry. In the graph below, correct option according to Kohlraasch law. So here the graph is plotted between A versus under root C, and different curvature values are given within the problem. So according to this, we have to depict which is the strong electrolyte and which is the weak electrolyte, right? So whenever infinite dilution got carried, any compound subjected, Kohlraasch law mostly applicable to what? Compound conductance at infinite dilution, right? So variation in the molar conductivity is given by lambda M is equal to lambda naught minus A into C to the power 1 by 2. A is nothing but constant. Lambda naught is nothing but molar conductivity at infinite dilution. Infinite dilution is nothing but maximum extent of dilution got carried where actual conductance of the compound will be there without affected by any kind of other. Sorry for that. So lambda M is equal to lambda M naught minus AC to the power 1 by 2 can be taken. This is a formula for Kohlraasch law, where A denotes what? A is the constant what we are taking. Lambda naught is nothing but molar conductivity taken at infinite dilution. And this equation in accordance with Debye-Huckel and Sagar. So if you are applying Kohlraasch law to strong electrolytes, it is called a Debye-Huckel and Sagar equation, right? And the Debye-Huckel and Sagar equation holds good only at the lower concentration level. So here graph is plotted between the value of A and the value of A was taken and the concentration, root of concentration was taken. So lambda value versus under root C concentration. If the given compound is strong electrolyte, the line will be in this sharp manner. If the electrolyte taken is a weak one, weak electrolyte is nothing but partial ionization. If the compound is possible, that is said to be a weak electrolyte. In case of weak electrolyte, it will be a curvature. You will get a curvature when we are plotting the graph between molar absorbability versus concentration, root of concentration. So here a curvature is obtained for the weak electrolyte. A straight line is obtained for the strong electrolyte. If we observe the given problem, given graphical representation, here a straight line is observed. C will be the graph line which corresponding with the strong electrolyte, and the curvature you can see with D line. This belongs to the weak electrolyte. This is in accordance with the Debye-Huckel and Sagar equation. So we are applying Kohlrausch law to strong electrolytes and weak electrolytes. Then it is known as Debye-Huckel-Ansager equation, right? So in accordance with the Debye-Huckel-Ansager equation, straight line is there, that is said to be a strong electrolyte. Curvature is there, that is said to be a weak electrolyte. C corresponds to strong electrolyte, D corresponds to weak electrolyte. That is provided in option number C. For question number 70, option number 3 is the correct answer. By this, entire series of CSR NEET GRF June 2014 Chemical Science Part B Series 3 have been completed. So thank you very much for your patience listening. Thank you, one and all.